Errors are an integral part of programming, and they can occur for various reasons, such as invalid inputs, unexpected condition, or resource limitation. In this video, we introduce one of Python's essential techniques for handling errors, raising exceptions. We explore why and when a function should raise an error, what developers should consider when making this decision, best practices for raising exceptions, and alternative approach to error handling, along with their pros and cons. Raising an error makes the code more readable and self-explanatory. It separates the error handling logic from the main code, improving code organization and making it easier to understand. Exception handling with errors raising enhances the robustness of your program by preventing crashes and unexpected terminations. It allows the program to continue running even when errors occur. Exception messages provide valuable information for debugging. When an error is raised, it typically includes details about the error type, location, and a stack trace, aiding in pinpointing the issue. Deciding when to raise an error in a function is a critical consideration. Here are some key factors to keep in mind. Function should raise errors for conditions that the program cannot recover from. For example, attempting to divide by zero is an unrecoverable error, and raising a zero division error is appropriate. Functions should raise errors when they receive invalid inputs or arguments that would lead to incorrect or undefined behavior. In other words, when the function's preconditions are not met. This ensures that the function is used correctly. When a function operates within a specific range or under a certain constraint, it should raise errors when these boundaries are violated. For example, when trying to compute the square root of a negative number. To maintain code quality and readability, developers should follow these best practices when raising exceptions. Raise the most specific exception that accurately describes the error. This allows for more precise error handling and provides clear information to developers about what went wrong. Using a bare except clause is discouraged, as it can catch unintended exceptions and hide errors. Instead, catch specific exception or use a base exception like exception sparingly. Exception messages should be clear, concise, and informative. They should explain what went wrong and, if possible, provide guidance on how to resolve the issue. In situations where resource cleanup is required, use a finally block. This ensures that specific cleanup actions such as closing file or releasing resources are performed. While raising exception is a powerful and widely used technique, there are alternative approaches to error handling, each with its advantages and disadvantages. Let's consider a very simple and quite useless function to illustrate raising an exception and how alternative approaches can be implemented. The function takes two parameters, a and b, and returns a divided by b. We need to consider the case where b is equal to 0, as a division by 0 is not a valid operation. First, let's consider an implementation that raises an error. If b is equal to 0, then raise a zero division error. Otherwise, return a divided by b. An alternative approach is to return an error code, that is, a value that cannot be confused with an expected result. In this example, the function returns none, a value that cannot be obtained from a division between two numbers. The function here returns a tuple, where the first element is the result of the division, and the second element is a potential error message, if a problem occurs. In this example, we can already see an issue with that alternative. The code does not return the simple result of a division. It needs to return two values. One could consider returning only the value of the division, or none if it is a division by 0. In that case, we lose the expressiveness of the error reporting as no error messages is provided. Having said that, some of the advantages of this approach are control over error handling at the call site, no exception propagation overhead. On the other hand, this approach has some drawbacks. It can lead to error checking boilerplate code, meaning using sections of code that have to be included in many places with little or no alteration. In addition, with this method, it is easy to overlook error checks, potentially leading to silent failures. And as mentioned earlier, it limits expressiveness in error reporting. Another alternative is to log errors. To that effect, we may import the module logging. The function logs the error before returning none. Again, none is used as a code error like in the previous alternative. There are two main advantages of this approach. It provides a centralized way to track errors for debugging and monitoring. In addition, it does not disrupt the program's flow, allowing it to continue execution. However, one of the most notable disadvantages of logging is that it doesn't provide immediate error handling within the function. Furthermore, it may lead to error information being ignored or overlooked. Finally, one could use the assert statement to check some condition, for example, that the inputs are valid. In our example, b must be different from 0. This approach is useful for debugging and identifying issues during development. It is easy to understand when an assertion fails. However, it is not suitable for handling errors in production code. In addition, it can lead to program termination if not handled appropriately. In conclusion, raising errors in Python is a fundamental aspect of writing robust and maintainable code. Developers should consider when to raise exceptions carefully, following best practices to ensure clarity and maintainability. Exception handling is considered to be the Pythonic way of dealing with errors and is widely adopted in the Python community. While raising exception is the most common method, there may be situations where other error handling techniques, such as returning error code or logging errors, are more appropriate. These alternatives are typically used when you want to handle errors in a specific way that doesn't involve terminating the program, or when integrating with external system or library that uses different error handling mechanisms. The choice of which method to use should align with the goal of the project, its maintainability, and the ease of debugging and maintenance. It's essential to consider the specific requirement of your application and choose the error handling approach that best fits the context. Thank you for watching and see you in the next video.